In this assignment, we're taking a look all at rates. Basically, it's all coming down to the idea of rate of change, which is actually a really critical concept in mathematics and a huge bridge to seeing how we can apply mathematics into the real world. And so we're going to focus entirely on this idea of rate of change in this assignment here. And a lot of it is familiar kind of ideas, but there's some subtleties that we do need to make sure we get down. So like in this case, we see if Tyler checks his pulse for 2 minutes, what is his rate if he counts 216 beats? So in the course of 2 minutes, he counted 216 beats. Generally, when time is in there, we want to figure out how much it is per time. So like in this case, we want to know how many beats he would be encountering per minute. And the cool thing is that when we already can start by saying that this is what we're going for is beats per minute, this actually now gives us a way that we can figure out how we do it. Because when you see that word per, or you can even use that word per kind of in your head as you read it, per means that you're going to be dividing it. So really, in order to figure this out then, we are going to do the 216 beats divided by the 2 minutes. And so if I do 216 divided by 2, that gives me 108. And therefore, my answer would be 108 beats per minute. We can use the same concept on this problem as well. In this case, we're driving 112 miles and we're using 7 gallons of gas. And again, we want to know the rate. And in this case, I'm going to want to figure out what my rate is as miles per gallon. Yes, you could also figure out gallons per mile, but it's not nearly as useful. The typical one that we would want to figure out is miles per gallon, so that's where we're going to start here. And so since I'm looking for miles per gallon, I'm going to want to do the miles divided by the gallons. So I'm going to want to have to do here 112 divided by 7. And when we do that, we end up getting 16. Therefore, our answer is going to be 16 miles per gallon. In this problem, there's a bit more words going on. So let's delve into the words to make sure they aren't going to throw you off. It says the table shows the proportional relationship between the number of pounds of organic bananas, which is represented by B, and the cost, which is represented by C, at Fruit World. Now, this concept of a proportional relationship, basically what this is doing is it's telling you that it's linear, if you recall what linear is telling us, or in other words, it is increasing or decreasing by a constant amount. So every time B goes up by 1, C has to go up by the same thing. That's what that term there, talking about a proportional relationship, is really telling us. So now that I know that, basically the rate for the situation is the rate of increase. So as whenever B goes up by 1, what is C going up by? That is what it would all come down to. And in this case, because our B values are going up by 1, I can go ahead and just use whatever that difference is between those two C values I've marked. However, you don't have to have done it that way. You actually could use any of the values, and I'll come back and explain why that is here in a moment, but let's first knock this out. Let's finish it out. So when B went up by 1 over here, C went up from 1.68 to 2.52. So in order to figure it out, I'm going to be doing 2.52 minus 1.68. That gives us 0.84, which means that this rate of increase here is 0.84. In other words, it costs 84 cents per pound of the organic bananas. But this is really the big thing that we're looking for, is that rate is going to be 0.84. And then because this is talking about a rate, we are going to go ahead and include those units. And so remember, it was cost for the bananas. So then I would go ahead and say that this is $0.84 per pound of bananas. All right, and that one is done. Now, that being said, remember I said that you didn't have to go between those two particular values in order to be able to figure it out. You actually could pick any of them. So for instance, what if I actually went from like the top to the bottom, from 2 to 7? I could do it that way. In this case, then, the C value, I'm going from 1.68 to 588. So let's go ahead and do that subtraction first. Let's do 5.88 minus 1.68. That gives us 4.2. All right, but you notice that's not the same as the 0.84. Why is that? Because that is how much it gained when it went from 2 to 7. And so I would also then have to say, okay, well, but that means that it went from 2 to 7 there. 7 minus 2 is 5. So when I gained 5 pounds of bananas, it cost me $4.20. So if I wanted to figure out the total cost per pound, I would then have to do this 4.2 divided by 5, which equals 0.84. And so it'd still give you the same thing, even if you chose different numbers to use, because it's all about saying how much did it go up by and how long did it take to go up that amount. All right, now in this problem, we have a table of values given. And in this case, it's asking us to figure out what was the average rate of change of annual sales. And so it's very much like that last one where we had the table, except we're going to have to just be paying close attention to which years we're going between, because it never said that it's proportional or linear or anything like that. So we can't assume that the rate will be the same every single year. So for this one then, for part A, we're looking to see what's going on between 2000 and 2001. So it's telling us that we're just worried about that part of it. So what I want to know is millions of dollars per year. And notice that sales here is done in millions, so that's why it's talking about millions there. You don't have to multiply or divide by a million to figure it out, because it's already in millions. So I need to figure out how much did the sales go up by between 2000 and 2001. In order to do that then, I'm going to do 186 minus 166, which equals 20. Notice that it took 1 year to gain that 20. Now, technically, I'd be doing 20 divided by 1 here in order to be able to get that, but of course I know 20 divided by 1 is just 20. And so my answer here would just be 20. And that's it. That is our final answer for that first one. But then in the next one, it says between 2000 and 2003. So this time, we're making that jump, which means I'm going from 166 up to 202. So I'm going to have to do 202 minus 166. That gives us 36. And so it means that it went up 36 between 2000 and 2003, but that is not my answer here, because it took multiple years to get there. How many years? Well, if I do 2003 minus 2000, that gives me 3. So it went up by 36 in 3 years. If I want to then figure out what is it in terms of $1 million per year, I would have to do the 36 divided by 3, which is 12, which means then that my answer for this one is 12. And so again, notice that yes, those two answers are different because we were never told that it was going up by the same amount. Hence why it also had to specify which years to look at for each of the problems. In our next problem, you notice that in this case it's telling us that we are going to try to find the constant rate of change. That's the same idea as what we've been looking at. It's looking for the rate of change, the rate, constant rate of change, average rate of change. They all basically mean the same thing. It's a matter of how quickly is this changing by. By including the word constant in this case, what it's telling you is that in this table, every time our hours go up by 1, our amount of miles will go up by the exact same amount as it does each other time with the miles. So let's go ahead and just pick 2 of our numbers, and then we can go from there. So first up, I'll just go from 8 to 9. Notice that is just 1 hour added. And I want to figure out in 1 hour, or in other words, in every hour, how much does the number of miles go up? And so if I'm going from 93 up to 103, that is 10. And you'll notice that no matter which pair of hours and miles I used, you'll notice that it's going up by 10 miles every hour because this one is constant. So it tells me I could have picked any of them. And so then in this case, since it's going up by 10 every hour, the number of our answer is 10. We do still need to include the units though. In order to be able to get that 10, we basically are doing 10 divided by 1, which you'll notice is the number of miles divided by the number of hours. That tells us then that our answer of 10 is going to be 10 miles per hour. Because remember, anytime we are seeing the word per, it means division. And so when I see that division, then I can translate it into per. And a way to remember that is another way that we can write miles per hour. If we want to write it in shorthand, people will write it like this: miles per hour. They use that slash, which of course also means division. Okay, next up, in this one, we have a graph that we're going to have to go from. So in this case, it says our graph shows a proportional relationship. So again, remember, we know that means that it's going up by the same amount each time between the number of genes and the cost. So for this particular one then, if we're going to figure out the rate, that means we need to know how much does the cost increase every time the number of genes increases by 1. Whenever you're looking at a graph, you should always be thinking that it's going to be whatever the y is per whatever the x is. So like in this case, it's going to be cost per genes. All right, so knowing that then, I need to know how much is it going up for every pair of genes. So what I'm going to do then is I'm going to try to figure out what it is at one of these points. And you'll notice that I don't really have one that's at a really nice, pretty point here. That is, it's not going like right through the grid lines. So I'm going to have to do a little estimation. So I'm going to look for one that's as close as I can find it. And actually the winner to me looks like it's probably this one up here, the very far one out there, because it looks like maybe that one is going through the grid lines, or at least it's very, very close to it. So that number down here along the bottom is 16, and it's 900. And so I'm going to try to then figure out when the cost is 900 and we go through 16 pairs of genes, what is that cost then? So I'm going to take that cost of 900 and I'm going to divide it by the number of pairs of genes, which was 16. When I do that division, it gives me an answer of 56.25. Now, how do I know that it's not supposed to be, say, 56 even or something like that? I don't. Remember, I'm having to estimate a little bit from the graph. And so there's a little bit of flexibility in how the answers are submitted here. And there's a certain range that would be acceptable. But for me, I would go ahead and say that it would be $56.25, since that's my best estimate. And that's going to be the dollars per pair of genes. And so then there's my final answer. All right, in this, our last problem that we're going to be taking a look at together in this video, we're looking at savings. So we're told that in the 4th month of the year, we have $376 saved. But then at the 12th month of the year, we have $528 saved. And the first question we're asked then is, what is your savings rate? Now, again, it's talking about a rate, right? The rate of change, the same thing we've been talking about throughout all these problems. in this kind of a case, we want to know how much are we saving every month, or in other words, the dollars per month. Now, notice when I can write it like that, that tells me how I'm going to figure out the rate, because it tells me I'm going to take the dollars and divide it by the months. So first thing I need to do is figure out how many dollars were saved over the time period that's shown. Well, in this particular case, that means I'm going from 376 up to 528. So I'm going to want to do 528 minus 376 to figure out what that amount saved was. And when I do that, I end up finding out that it's $152 saved from the 4th month to the 12th month. Well, remember, I want to be able to break it down to how much was saved every single month. So I got to divide it by the number of months covered. So that other part then is that I'm going from the 4th month to the 12th month. So I'm going to have to be doing 12 minus 4, which of course is 8, to figure out total months. It can be helpful as you do this to include the units. So like the 152 is your dollars, and the 8 was your months. If you write down that sort of thing on your own work as you do these, it's going to help you to keep track of what number is what and help you to not lose track of them. All right, so then if I want to know my savings rate, then I'm going to be figuring out dollars per month, which means doing my number of dollars divided by my number of months. So if I do 152 divided by 8, I get 19, which means for this problem then that my savings rate is $19 per month. And just knowing that answer is actually going to allow us to now go and figure out what those other two answers are. Because notice there are 2 more questions in this case. So the next question says, how much do you save every 5 months? Well, if we're saving $19 per month, then I'm going to take my 19 and I'm going to multiply it by the number of months, which is 5. Which means that in 5 months, we would save a total of $95. And I'll go ahead and use the dollar symbol there, but I also could have just written the word dollars after as well. All right, and the last one, how much did you have saved on the 17th month? What makes this particular problem extra tricky is because it's not saying how much did he save every 17 months, but rather how much do you have saved on the 17th month? Well, that has to account for the fact that we know that after 4 months we were at 376, or after 12 months we were at 578. We're going to need to use one of those pieces of information in order to be able to answer this. So the way I'm thinking about it is I'm saying, well, at the 12th month, I have 528. So 12th month, I have $528. And I want to know how much there's going to be on the 17th month. This is my answer that I'm looking for. So the question is, how many months have passed? Well, notice there, going from the 12th month to the 17th month is plus 5 months. Well, isn't that the same as what we did up here on that last one? Every 5 months, we know that we save $95. So that means there's going to be another $95 saved. That gives us 623, which means then that on the 17th month, we would have a grand total of $623 saved.